and welcome to Tech to Tech presented by KYZEN, where we will explore common cleaning questions and answers. Let's get started. I would like to introduce KYZEN's own Jeff Deering.
Welcome, and thank you for joining us today for another Tech to Tech with Team KYZEN. The topic of conversation today is under stencil wiping, both basically understanding the process and working with a handful of parameters to make sure we can optimize that process. And before we get started, I'd like to mention that there's a 4-part series on our Tech to Tech website titled Stencil Cleaning Series, that if you need some more in-depth data based on the information I share with you today, please feel free to reference those shorts on the internet that are on our Tech to Tech website, again, titled Stencil Cleaning Series. Let's get started. Our outline today is going to be a 4-simple-step approach. First, we need to select a chemistry that dissolves the flux. Next, we'll need to optimize the settings for each chemistry tested based on the fluid delivery system, as well as the paper-solvent interaction. Third, we always want to consider ending the wipe sequence with a vacuum. And last, we want to make sure we test the chemistry in the printer instead of off the printer using SPI testing, as well as an under stencil inspection. What do we need to know about printer chemistry? Well, here we have a simple breakdown of the features of our 3 options. Our first option is a solvent-based chemistries. You need to keep in mind that some solvents evaporate quicker than others. They usually provide a wider range of flux solubility. You also need to remember the paper can impact the solvent usage. And the biggest issue with solvent-based chemistries is not adjusting the default settings, which is something we'll touch on as we go through this presentation. Now moving into water-based chemistries. Some materials split. The evaporation is not everything and can vary a lot. Again, the paper absorption rate affects the usage of the water-based chemistries. There's also a risk of leaving the chemistry on the stencil, which can mix with the paste and could cause cross-contamination. This also holds true when you add water to IPA. Again, the biggest issue with water-based chemistries is not adjusting the default settings. And lastly, we have IPA. IPA does not dissolve many pastes and can cause a gooey mess. It typically affects the first print after a wipe. Sometimes it evaporates too quickly, which also can lead to it consuming more volume than an engineered chemistry when you take into account the amount needed to wet the paper and clean, plus the evaporation. Next, I'd like to talk about the common problems an engineered chemistry can fix. First and foremost, some common solder paste defects: poor gasketing from flux buildup and insufficient pads. Engineered chemistry can help increase your prints between wipes from 1 to 2 to however many we can determine when we work to optimize your process. It also increases the number of prints between off the printer cleaning. And most importantly, engineered chemistry provides a more consistent transfer efficiency between prints and wipes. All of this, even without nano coatings on your stencils. Now let's take a closer look at some of the limitations of IPA. We're all familiar with the no-clean fluxes that have changed compositions lately. They can leave flux streaking on the stencil. They can damage the printer rails and tooling. And in some cases, they cause a gooey mess like I mentioned before. IPA dries fast, again, having a higher consumption rate. It requires more volume to wet the stencil, like I had mentioned before. It can be a poor cleaner. It dries out apertures, which results in poor print release. It's not recommended by printer companies. And most importantly, it's flammable. Back to our outline. Now that we've discussed selecting the chemistry that helps dissolve the flux, I'd like to discuss in a little more detail optimizing the settings for each of those chemistries tested based on the fluid delivery system and the paper-solvent interaction. It's important to understand that 90% of users never change the factory default settings. What you see here is a simple diagram, as well as a chart of some of the parameters that come default from the factory. A few of them that we'd like to address, there's always a min and a max, but we need to make sure we address the wipe speeds for the wet, the dry, and the vacuum. We also want to address vacuum pressure, and one of our goals is to decrease that wipe frequency. Without doing all of that, your process can lead to inconsistent printing. Now, if there's too much solvent, you're going to leave excess solvent behind on the bottom side of the stencil, and it can mix with the paste, causing defects. Too little solvent will not effectively remove the flux from the bottom of the stencil or apertures, again, causing defects. Please keep in mind, solvent should be consistent along the entire length of the paper. And remember that those settings can be adjusted based on the solvent-paper interaction. The tech tip here is, good coverage on your paper is typically somewhere between 15 and 20 millimeters in width. Now I'd like to take a closer look at some of our printer solvent settings. When discussing water-based solvents, the default solvent speed stroke we've found to be effective, as well as the default index speed. But when it comes to the solvent speed bar, it's much more effective at 5 inches per second, which saturates that paper at approximately 16 millimeters in width. This indicates that water-based materials may need to have more rotations than solvents to be effective, but less than standard default settings. When we look at solvent-based chemistries, the default solvent speed stroke again is effective, as well as the index speed. But we also need to pay attention to the solvent speed bar. With solvent-based chemistries, it's much more effective at 3 inches per second, which again saturates the paper at a 16 millimeter width. But this indicates that solvent-based materials may need to have less rotations than the default settings or water-based solvents to be effective. And an important note here is the paper should be damp and not wet. Now, when discussing the wipe sequence in paper, there's a few facets that we need to look at. 1. Most printers allow the operator to program a variety of wipe sequences using a wet stroke, a dry stroke, and a vacuum step. The paper that we're using, you need to keep in mind that not all papers are the same. You have your synthetic fiber paper, you have your natural fiber paper, and it's extremely important to remember that the type of wipe paper can critically impact the speed and the wipe sequence of the process you're handling. Again, why so much talk about the paper? It's where the paper meets the chemistry, or the rubber meets the road. Each paper type has different absorption rates and properties, and each chemistry has different surface tensions and densities. Using the right paper can cut your paper and chemistry consumption in half. Now let's look at some simple printer setup tips. First, we want to check the blades for proper condition and ensure that they're tight. Next, let's confirm the board support is sufficient by pressing down on the stencil in solid areas above the board. Always remember that the wipe recipe for before and after a pause should be wet, wet, dry, dry, vacuum, vacuum. We also need to keep in mind and try to keep the board snug against its rails. And as you'll hear again, ending in a vac step is highly recommended to make sure we optimize the process. So back to our 4 simple steps. We've selected the chemistry. We've discussed optimizing the settings for each chemistry. Third, we always want to consider ending the wipe sequence with a vacuum. And lastly, we want to make sure to test the chemistry in the printer rather than off the printer using SPI testing and under stencil inspection. When it comes to SPI testing, we need to keep in mind 2 things. QFPs show the best bleed out tendencies, and BGAs show the transfer issues. BGAs are considered the best test for improvements when changing variables, and if further optimization is needed, it can be achieved by exploring alternative wipe sequences. In conclusion for today, it's important that we understand the key elements in the solder paste printing process and how they interact to make sure we select the ideal chemistry. After we do that, it's pertinent that we maintain control of the process. It's where most of the rework comes from, and it's where the money is in SMT. Keep in mind, if specific defects continue to occur, follow logical troubleshooting guidelines. And when push comes to shove, make sure you consult your local KYZEN team member for technical support. Before we finish today, I'd like to make sure we review some frequently asked questions on this topic. First, how do I know what the best chemistry is for my printer? Well, alcohol is for sure not the best one. The first step to finding the best chemistry is to get in touch with your cleaning supplier, and they can send you in the right direction. Second, our default settings process parameter recommendations from the manufacturer. They're made to change. You will save a lot of money if you spend time making sure you optimize those settings, as we discussed in this slideshow. Third, do engineered solvents clean better than IPA? Absolutely. An engineered solvent will help your printer process compared to the IPA every time. And why is it unsafe to use IPA? Well, first and foremost, it's very flammable. But it also does not solubilize paste as well as an engineered chemistry with current paste technology. Thanks again for your time, and please feel free to reach out to your Team KYZEN representative with any further technical questions or your cleaning needs.
Thanks, Jeff, and thank you guys for tuning into this Tech to Tech session. If you would like to discuss this topic further or have any questions not answered in the session, please contact your local KYZEN regional manager or send an email to tech@kyzen.com, and we will have someone follow up with you as soon as possible. And if you like this video, be sure to follow us on our social media platforms for more expert cleaning content.